This is the introductory essay to UFT 139, and it is on the fundamental errors in the Einstein field equation. In this paper, the fundamental errors in the Einstein field equation are pinpointed with precision. It is shown that the academic subjects of general relativity and cosmology are so riddled with errors that they are meaningless to science. The latter was defined by Bacon as being a subject that consists of the simplest possible and mathematically correct hypotheses that can be tested against experimental data. The Einstein field equation is incorrect due to its arbitrary neglect of a fundamental property of spacetime called Riemannian torsion. Derivative theories of general relativity and cosmology, such as string theory, Big Bang, the existence of black holes, and the existence of dark matter, are sequentially incorrect due to the neglect of torsion. These theories are essentially anti-Baconian. They are incorrect mathematics, and incorrect mathematics cannot be tested against data. They contain many ad hoc assumptions about the existence of unobservables, assumptions that just serve to compound the original incorrectness of the Einstein theory. The fundamental idea of general relativity is that physics, or natural philosophy, is based on geometry. This idea goes back to classical, Celtic and Greek times, when geometry was considered the epitome of beauty. The idea was used for about 1,000 years after the Greeks, right up to the time of Kepler around the turn of the 17th century. It was thought that the orbits of celestial objects were governed by the music of the spheres. Orbits were thought to be governed, therefore, by the beauty of geometry, in particular the circle. Real orbits were described by epicycles, circles added to circles. This idea was anti-Baconian in the sense that nature was forced to conform to human ideal. This is precisely what is happening today in cosmology and general relativity. The general public is being told, quite cynically and wrongly, that there exist elements in nature that are figments of fantasy based on an incorrect equation, the Einstein field equation. There has therefore been a retrograde movement that has corrupted the scientific enlightenment brought about by figures such as Copernicus, Bray, Galileo, Kepler, Bacon and Newton. These scientists and philosophers developed the fundamental methods of natural philosophy by developing a mathematical description of data. This was a long and slow process which culminated in the Newtonian synthesis. The equations of motion of all objects were described by three basic laws using mathematics that were correct within the context of its time. These mathematics were again based on geometry in Newton's original development in a book called The Mathematical Principles of Natural Philosophy. This book was based on experimental data meticulously gathered by astronomers such as Tycho Brahe, and gradually synthesized with much effort into the three planetary laws of Johannes Kepler. Isaac Newton developed the mathematics to describe these laws, as the title of his book suggests. It is not widely known, even now, that these mathematics were still based on geometry. However, the idea that nature and thus geometry were manifestations of subjective beauty was abandoned by Newton. Geometry was used as a means of describing observation as demanded by the philosophy of Francis Bacon. This is known as the idol of the cave philosophy and is based on the ancient Greek philosophy of Plato. The word idol in this context is based on the classical Greek for dream. The cave denotes the darkness of the human mind when unguided by experiment or measurement, by data taken from nature. The human mind produces fantasies that become wilder and wilder, which is exactly what we see on our television screens today. Big Bang that never was, black holes that do not exist, dark matter that is not there in reality, a string theory that has never been proven experimentally. All these flow from a flawed geometry as shown in this paper and earlier papers of this series on the www.aias.us website. Gradually, the mathematical methods used by Newton were simplified and extended to include rotational motion. Many mathematical methods were developed in the 17th, 18th and 19th centuries by figures such as Leibniz, Euler, Lagrange and Laplace. These extended the original Newtonian ideas into a subject known as classical mechanics. In the context of cosmology, celestial mechanics by Laplace was a high point of the Enlightenment. Later in the 19th century, Hamilton profoundly added to the subject. It was thought that the ideas of Newton, albeit extended, were adequate for the description of nature. However, all that changed dramatically in the late 1880s following an experiment by Michelson and Morley which contradicted common sense. An experiment which showed that the speed of light behaved in a way that was not compatible with Newtonian ideas. Around the same time, Oliver Heaviside produced his vector equations of classical electrodynamics from the earlier quaternion equations of James Clerk Maxwell. The Maxwell-Heaviside equations were not compatible again with Newtonian ideas, so classical dynamics and classical electrodynamics obeyed fundamentally different laws. The problem arose of reconciling what appeared to be two entirely different subjects of physics. Following upon the results of the Michelson-Morley experiment in about 1887, Oliver Heaviside began to correspond with George Francis Fitzgerald on how to produce a theory to explain the perplexing result of the experiment, that the speed of light appeared not to vary in different directions of frames of reference. The subject of relativity was brought into being by these discussions between Heaviside and Fitzgerald in the late 1880s. The subject was later developed by many scientists, notably Henrik Anton Lorentz and Henri Poincaré, who began to implement the then new tensor calculus. Around the turn of the 20th century, 1900, the Maxwell-Heaviside equations were put into tensor format using the Lorentz transformation from one frame of reference to another. The Lorentz transformation is generally considered to be the key equation of special relativity, a subject that is defined by classical electrodynamics. This is because the Maxwell-Heaviside equations obey the Lorentz transformation, not the Galilean transformation of the Newtonian laws. The Lorentz transform implements a vector in 4 dimensions, 3 space dimensions and 1 time dimension. Therefore, time is no longer independent of space as in the Newtonian ideal. Space-time is not an idea that was introduced by Einstein. It was introduced by several earlier scientists, notably Heaviside and Lorentz.